A block B of mass 0.8 kilograms is pulled across a horizontal surface by a force of 6 newtons, inclined at an angle of 60 degrees to the upward vertical. The coefficient of friction between the block and the surface is 0.2. Calculate the vertical component of the force exerted on B by the surface. So here is a figure. Here is the force of 6 newtons. We break down this force. We get a horizontal and a vertical component. We can find out the vertical component. This is the 60 degrees angle, and this is adjacent of this angle, so f sub y is equal to 6 times cosine of 60 degrees, because this is 0.5, this is 3 newtons. This side is equal to this side, and it is opposite of this angle, so we get f sub x 6 times sine of 60 degrees, it's 5.2 newtons. There is the gravitational force, it's m times g, and the normal force and the friction force. Sum of the vertical forces is equal to 0. The positive direction is upwards, so n plus f sub y minus m times g is equal to 0, so we get this equation, and then n is equal to m times g minus f sub y, and it's 4.84 newtons. Calculate the acceleration of B. There are two horizontal forces, F sub x and the friction forces. First we calculate this. The friction forces is equal to mu times n. It's 0.2 times 4.84. It's 0.968 newtons. We can apply Newton's law. Sum of the forces is equal to m times a. The positive direction is to the right. This is the positive force, and this is negative. So we get 5.2 minus 0.968 is equal to 0.8 times a, and the acceleration is 5.29 meters per second squared. The 6 newtons force is removed when B has speed 4.9 meters per second. Calculate the time taken for B to decelerate from a speed of 4.9 meters per second to rest. Here is our figure. there are two vertical forces, m times g, and the normal forces. They are the same. And one horizontal forces is the friction force. It's the coefficient of friction times normal force. And this is our positive direction, and we can apply Newton's law, and we get the acceleration. And we know that the acceleration is equal to change in velocity over change in time. Change in time is equal to change in velocity over acceleration. The initial velocity is 4.9 and the final velocity is 0. So after substitute we get the change in time, it's 2.5 seconds.